Hi everyone, and thank you for watching this. We are here for another session on knapsack problems. This is the last one of them. We saw a brief introduction of what the general knapsack problems are. We also saw the binary knapsack problems and one implementation for them regarding the portfolio optimization problem. And then we saw how to solve a quadratic knapsack problem, also with an example that was more related to items in a knapsack. Um, that is the last one. These two sessions, the binary and the quadratic, have the theory and then the code implementation part. And what here we will conclude all these knapsack problems section with other different combinations that are embedded in the knapsack problems list. So let's see a bit these ones. We won't implement them. It's just for you to know them, just in case you have any problem that can be modeled into some of these. You will know the name and what are they. So you know you are that is one of these problems. So first of all, the bounded knapsack problem, where instead of having a variable x sub j, that is either we invest or not, or here either we pick the item or not. The variable, what will mean is um, well, we can in the binary form we can also say either we pick one item or not. What we will reflect here with the variable is how many of those items will we be getting. So we are turning the binary variable into an integer variable where we can choose um, uh, a number of items, well, the same item a number of times. That is limited. This is the limit. Here we call it C. So as you see here, for example, for this would be 3. So we can either pick 1, 2, or 3 of this exact item. So imagine that you have a load for a truck and you have 3 TVs and I don't know, 4 mobile phones and 6 general boxes. So you need to know how to arrange them into the track so you get the most revenue afterwards selling them. So this is what we are talking about right now. Um, this is different. The modeling, the mathematical modeling will be different because we are treating with integer and not binary variables. And we have a different limit for each of the types of items. So you can convert it into some kind of binary problem if you just think about each of these items as one separate item. That would be a binary problem. Just some of them have the exact same profit and the exact same weight. The thing is that the modeling will be different. So yeah, this is one of them. Um, the unbounded knapsack problem, it's it's really similar, but we don't have a bound. We don't have a limit of those items. We only know the types of items that we have, but we don't have a limit of them. We don't have a limited stock. So you just have to choose how many. In this case, we cannot do the trick that we said before of making each of them a binary variable because we would have infinite binary variables. So we need to model it as a problem with integer variables. And that's different than what we've done until here. Um, on other side, we have a different type of knapsack problems that are depending on multiple classic knapsacks are constraints. multiple things that are not the items related to the item. So, for example, in the multiple choice knapsack problem, what we have is we have different classes. Let's say we call them here N1, N2, and 3, and we have different items in those in those, let's say, classes. So what we need to do is classify the items in the classic in the classes, and you need to take one of the items in each of the classes. So this is the constraint that we are adding. We for each of the classes we need to choose one of the items, and then we have the rest. We have the weight for all of the selections. We will have the weight constraint, and we will have the profit constraint. Um, so yeah, this iterates also between the number of classes. So we have a constraint for each of the classes, and we have the general ones that we already know. We also have the multiple knapsack problem that would be instead of going to for the distribution of items, like here, we will have several knapsacks, and each of them will have a different weight, so a different limit, so a different penalty constraint. And we need to order them in the best way. As here, 10, 12, 15, all that. And finally, we have the multiply constraint knapsack problem. That is, okay, I have the same items that I have had in the beginning. I have the same bag, the same knapsack that I had in the beginning, but now I'm adding another constraint on the limitation. So it's not only limited by the, for example, by the weight, it's also limited by the capacity, so by the volume. This is why we have here the volume of each of them in liters. Um, so yeah, this is another kind of problem. Um, we get another dimension of those weight constraints. Um, Many of those start adding additional constraints. There are other ones that are not adding additional constraints to the model, but are changing the variables that we are talking about. So yeah, this was a brief conclusion, so we know other kinds of knapsack problems. I hope that this all was useful, and yeah, see you in the next session. Thank you for watching.